actually changing the stuff inside of the classes. We talked about protecting variables, and I also mentioned that most of the time when we start with variables, those variables are private. But if the variables are private, then how do we actually get to them if you can't access them from outside the class directly? And the answer is we use what we call accessors and mutators. Accessors are also called getters, and mutators are also called setters. So getters and setters, accessors and mutators, they mean the same thing. Yes?
I know some languages have like a default get set up.
Yes,
Does Java have something like
Java
that?
does not. So the question was, does Java have any default get set functions? And then sadly, no. This is one of my favorite features of the C# language, is that it has like built-in defaults for these. Java does not have those, unfortunately. So basically what that means is that let's say that we wanted to be able to set the level of a monster, we have to have a function called setLevel. And this is not a special name, this is the convention, it's the most common, but it's not the only way. So we usually have setLevel, and then if we wanted to access the level, if we wanted to get the information about the level, we would have another function called getLevel. So we have setLevel to set it, and getLevel to get it. So if we want to look at how this turns out in code, we might have some program, and we create a new monster called Pika, and then let's say we wanted to print out the starting level. If we print out Pika.getLevel, so we're calling the function getLevel inside of the monster class, then what is it going to return to us in this case?
0.
Right, it's going to give us 0 because that's the default value that we've assigned. So whenever we do an assignment like this, that means that's what the default value is going to be for any objects that are created. So it's going to give us a 0. Then if we turn around and we do Pika.setLevel10, then that value is going to change to 10. If we print it out again, that's going to give us 10, right? And here I'm calling the getLevel function again. So this probably seems like a lot of work to change a variable, and it is. But then again, if we're storing a variable in a class, that means there's something unique about it that's directly associated with that class. So we want to add a level of protection whenever we have class variables so that we don't accidentally change things. This is all part of that concept of encapsulation that I mentioned before. The idea behind encapsulation is that you put layers of protection around your code. You try to prevent mistakes from happening by preventing access except under the conditions that you set. So if I wanted to make something that could only be read from the outside but couldn't be changed from the outside, what might I do differently? If I only wanted people to be able to read the level but not to change it, what do you think?
Make it private?
Oh, that's a good. That's one answer. So he said make it private. Right, I could make the set level private, right? But what else could I do? Is there something else? I could just not have this function at all, right? I just leave out the setter method. Right? That's probably the easiest way. This is a way that we can make read-only variables. That's a pretty common approach in classes. All right, any questions about our accessors and mutators? Wow, this class got thin. I hope they don't want any help on the project. Another thing we might want to do, somebody asked about this earlier. Oh, I did hear there was a class, or there was an exam or something, so maybe that's what some people are heading to. I'll use that to coax my ego. Somebody asked earlier, man, it's a lot of work to change all these variables line by line. I wish there was a way we could just do it at the beginning. And there is. That's what we call a constructor. A constructor is a way to initialize an object to some specific set of values. So let's say that we have our class monster and we have these private variables name and level. Then I can create a constructor, a way to create a new object that takes in two parameters, underscore name and underscore level variable. Then I can set the name equal to underscore name, and I can set the level equal to underscore level. The way that we would turn around and use this is that in the program, and I really messed that up. In the program, when we want to create a new monster object, rather than just having the open parentheses, close parentheses, I actually put the values in here. So what that's going to do is that this when I say new monster and I give the variables, that's going to go into the constructor. Name is going to become chew, underscore level is going to become 10, and that's going to set the actual variables of the object itself. So this is how we can actually construct an object all in one line. On the other hand, if I define this, something interesting and unique happens. If I define a constructor that takes parameters, that one that doesn't take parameters, that disappears. Java does not create it. So this becomes illegal. This becomes something that will not compile. So once I add a constructor with parameters, I can't use that old default one anymore. It becomes something that will cause a compile error at that point. So this is how we create objects and initialize them at the same time. Yes? The question was, do I still need to initialize name and level if I have it in a constructor? No, I don't actually. I don't have to have this unless if I have multiple constructors, which I'm going to show next, then I would still want to have that on. Does that answer your question? But in this case, no, I wouldn't actually need it. Yes?
In your monster class, can you have a second method called monster, but that didn't accept any arguments?
Oh, that's a good question. The question was, could I have another one of these constructors? The answer is yes. I'm going to get to that in just a second. Hold on to that thought. We're going to get there in just a minute. Anyone else? Yes?
Explain again real quickly why monster compile.
Oh, why doesn't this compile? Because before I didn't have a constructor at all. If I do create a constructor, then if it has parameters, and if I don't have one that doesn't have parameters, basically you can't do this anymore. That's just the Java rule, right? Is once you explicitly create a constructor, it won't create a default one anymore. So what actually happens in the background is that if I don't have one, Java just creates an empty one for me. If I do create one, then it'll only let me make stuff using that constructor. Does that answer your question?
So completely it'll bypass your other public classes.
Well, it doesn't bypass it, but it replaces what we call the default constructor. Because basically, if you don't create one of these blocks of code, like if I didn't have this, Java just creates a constructor for me that doesn't take any arguments. But because I created this, Java's not going to do that. Yes?
So in order to have an object to make up the parameters, you have to make a constructor that doesn't have it.
Yes, if you have at least one constructor, then in order for it to create an object that doesn't require any parameters, you have to have a constructor that doesn't take parameters. Yes. Yes. What happens if I put name? Do you mean this line here, or okay? Well, in this case, technically, this is a different variable because it has the underscore in front of it. What if I use the same variable name? Well, that's a good question, and it's actually on it. So you ask really good questions that are on my future slides. So the short answer, though, is that if we use just name without an underscore, then we wouldn't be able to get to this from in here. Unless I use the keyword this. Yes, which we are going to get to, but which is on the future slide. So yes, that is how we would do it. Okay, anyone else have any questions at the moment? All right. But I appreciate the questions. Even if they are on future slides, I totally invite you to ask them. So, one thing we can do is like, well, hey, what if I want more than one way to build an object? What if I want more than one way to initialize an object? I can have overloaded constructors, which means I have more than one. I'm overloading the constructor call. So let's say that I have this monster function. If I want, I can have an empty constructor. That's what this is. This is just shorthand. I could have like a bunch of lines, and I could put a brace here and a brace here, but this is just, it's a block. It's an empty block, right? Open curly brace, close curly brace. That's an empty method. So that's a default constructor. But I could also have one that just takes a name. If I have one that just takes a name, then I can change the name, but it'll still initialize the level to 0. And I could also have one that takes 2 parameters. That takes a name and a level. So these are three different ways that I can construct an object and I've created 3 different constructors. They all act a little bit different, but they all allow me to create the same kind of object. So the default constructor, if I have some variable named rando, I could create a new monster, right, for rando, and I can put no information in it, right? So that's going to call the default constructor, so it's going to be submonster0. If I put a single parameter in, like if I create a new monster called jiggle, its default level will still be 0. And finally, if I have a 2-parameter constructor, I can have the monster chew with level 10, and that's going to call this last one down here. So these are 3 different ways that I can create an object, right? So I've just defined different ways to create the same thing. We can do the same thing with other methods, which is what we're going to look at next. Yes, do you have a question? No, you're good? Okay. Yeah, so we can do this with other methods as well. But constructors are probably the most common use case of overloading. Okay, so let's talk about overloading methods. The idea behind overloading a method is you can have one method name, but you could use that method name to take in different types of parameters. And as long as we vary those parameters, we can do that. So we've seen it with constructors, but I can also do it with other types of methods. So let's say that we had this monster, and then I had a function called increase level that would let me put in a number of levels to increase the level by, and then I would add that amount to the level. I could have another version of that called increase level that took no parameters, and it could just increase the level by 1. So in this case, increase level with no parameters calls the other version, the overloaded version, increase level with an amount, and it passes in the variable 1. Then if I go and I execute this, right, let's say I create a monster Pika, right? And this is what our heap looks like. This is simplified. I'm not bothering with the stack at this point. Right, we create this object. It starts out with level 0, and in this case, the name's not pointing at anything. And then I assign the name to chew, and I assign the level to 10. Right, that's what this constructor does right here. Then, if I call increase level, that's going to go down here, and that's going to call increase level 1. Which is going to go up here, and it's going to increase that to 11 from 10. Then, let's say that I call increase level 10, that's going to go directly to this version, and it's going to increase it from 11 to 21.
So just as long as you specify parameters and have a different method?
Right. As long as the parameters are different, even if they have the same name, then you can make different calls. And you can have different implementations as well. Anyone else? I know you're getting tired. We're almost there. Hang in there. So, speaking of what somebody asked me about earlier, let's say that you had a class, but you didn't want to bother with those underscores that I was using, which you can always use, but if you don't want to, that's okay too. Let's say you wanted to actually use the variable, the same as the variable names inside of our constructor. One way that we can differentiate between a variable scoped for the method and the variable of the class is to use the this operator. This is a special keyword in Java, and it also exists in C++ and many other languages. And it means that you are referring to the current object. It is a reference to the current object. So I could do this.name equals name. This.name is going to be the one for the object. The one without the this keyword is going to be the one that came in as a parameter. And I can do the same thing with level right here. So this is pretty straightforward, but this is mostly a stylistic issue. Some people like to use the this keyword, some people don't. It's really up to you. I don't know anybody that's really strict about it, but there's a stylistic difference. And some people say that using the this keyword is a little bit easier to read. So I believe this is almost the last thing. So one of the things we talked about briefly in the past was static methods. The idea behind a static method is it's a method that doesn't need an object to operate. We can also have static variables. Static variables and static methods exist outside of an object, and they're contained specifically within the class. So they are universal to all objects of the class, and they exist even when no object does exist. So, for example, one of my favorite games is Pocket Mortys. So, I'm a fan, it's true. And so, let's say that I have a class for my Morty, right? Maybe I want to define some maximum level that any Morty can reach, and maybe that's going to be 100. It wouldn't really make sense for that value to be stored in every single object. That would just take up memory and it would be pointless. Instead, I can make it a static variable, and that way only one max level variable exists for everything. It exists in the class instead of as part of the object. I might also want to keep track of how many Mortys I have created so far. And to do that, I would use a Morty count. And I made a mistake because this is also supposed to be static. So I'm going to fix that right now. There we go. Okay, so I might have a private static integer Morty count that starts at 0. This is going to keep track of how many Mortys I have. The reason it's important for a count to be outside of any object is because we're counting out how many objects there are of a type, right? It doesn't really make sense for that value to be stored in the object itself because it would be multiple copies. So, and then of course we're going to have a name and a level for each Morty. And let's say that our constructor, just uses the, and I apparently messed this up because I left out, boy, I really botched this slide. Just pretend there's an underscore there. So I set the name and the level, and then maybe every time in the constructor, I also might want to increase the Morty count. So every time I create a new Morty, to fight in Pocket Mortys, I'm going to increment the number of Mortys that there are. It'll go up by 1. So when I create the first one, it'll go from 0 to 1. When I create the second one, it'll go from 1 to 2, and so on and so forth. Yes?
Where did you say the underscore went?
The underscore, it's a typo.
Oh, where's it?
But here, you know what? Just to keep everybody sane, I'll fix it. Here we go. Okay, so there. Should be repaired now. Yeah. Okay. So, and finally, if I want to figure out how many Mortys have been created so far, I can have a get count variable, and that'll tell me how many Mortys have been created up to this point. Any questions? All right, we have one more thing to cover, and just enough time to cover it, and that is the object class. So we're going to be learning more about derivation and about inheritance later on in the class. But one thing that's interesting is that every type in Java that is not a primitive is an object. It's a reference type. Every reference type inherits from the class object, which is a little confusing in terms of terminology, but it's capital O object. It is a class. And every type that is not a primitive inherits from it. It is an object. So here's an example of some code that I could use to look at that. Let's say I created a new Morty called Scruffy, and then I can actually check to see, using a special keyword called instance of, I can check to see if my Morty is an instance of the class object. If it is, I can print my Morty as an object, and if it's not, I can print do not objectify the Morty. And it's going to print out, in this case, my Morty as an object, because everything that is not a primitive is an instance of object. It is a member of the object class. Okay, any questions? Yes?
Does that have to do with like inheritance or something?
It doesn't have to do with inheritance, it absolutely does. And that's what we're going to cover next time. So. All right, thank you very much.